Hello students, in this module we would continue with the problems on continuity. Here we have two important problems. The first one says examine the continuity at x equal to pi by 2. So here we have to discuss the continuity of f of x at x equal to pi by 2. As you all already know now, f of x will be continuous at x equal to pi by 2 if and only if limit x is tending towards pi by 2 f of x should be equal to the f of x at x equal to pi by 2. But from the question, when f of x at x equal to pi by 2 is already nothing but 3. So solving for the left hand side, that is limit f of x when x is tending towards pi by 2. The equation which we have from the question is 1 minus sine x upon pi by 2 minus x the whole square. Students, as soon as you see this equation, what do you remember? You remember that you can see x is tending towards a constant and you have a difference in the denominator. That is, for this type of questions where x is tending towards pi by 2 and x minus pi by 2 is present in the denominator, we have to substitute. So when we put x as pi by 2 plus h, so when x is pi by 2 plus h would be 0. In that case, when x is tending towards pi by 2, h has to tend towards 0. So students, over here in this case, the equation is in the form of x. So we are now writing the equation in form of h. So what is the equation? Limit h is tending towards 0. 1 minus sine of pi by 2 plus h the whole upon pi by 2 minus of pi by 2 plus h the whole square. So solving it ahead, what would the equation be? You already know that sine of pi by 2 plus theta is cos theta. So over here, sine of pi by 2 plus h would be cos h. That is 1 minus cos h upon pi by 2 is getting cancelled and what you have is minus h the whole square. So equation would be 1 minus cos h upon h square. 1 minus cos h and the denominator is in square terms. So we have to use half angle formulas. So we know that 1 minus cos h is nothing but 2 sine square h by 2. So the equation would be limit h is tending towards 0, 2 sine square h by 2 upon h square. As soon as you see this equation, 2 is a constant, it is kept outside. But what you have is limit h is tending towards 0, sine of h by 2 upon h the whole square. So what is incomplete? The value of constant, that is sine theta upon theta. But here you have h by 2 upon h. So for balancing coefficient of x, we multiply and divide by 4. Why 4? Because here you have square terms. Therefore, the equation would be 2 into limit h is tending towards 0, sine of h by 2 upon h by 2 into 2 the whole square. So when that 2 square comes out, the equation would be 2 into limit h is tending towards 0, sine h by 2 upon h by 2 into 1 by 4. In this case, if you observe, the equation is of a standard form, limit h is tending towards 0, sine h by h, and it is nothing but 1. So the equation would be 2 into 1 by 4. That is 2 is getting cancelled with 4. So the answer which you get would be 1 by 2. We already know limit f of x is not equal to f of x at x equal to pi by 2. And hence I can say that it is discontinuous at x equal to pi by 2. Moving ahead with the next problem. What does it say? Find the value of k so that the function is continuous at an indicated point. Students, mark this point, very important. They have already said you that the function is continuous. I can say if a function is continuous, the equation is already satisfied. Which equation? Limit x is tending towards 0 minus f of x should be equal to limit x is tending towards 0 plus f of x should be equal to f of x at x equal to 0. In this case, f of x at x equal to 0 is your required value, that is nothing but k. So for solving, we consider the left hand side, that is limit f of x as x is tending towards 0 minus. So the equation would be 1 minus cos 4x upon x square. We know the half angle formulae as we have solved earlier. 1 minus cos 4x would be 2 sine square 2x. So limit x is tending towards 0 minus 2 into sine square 2x upon x square. It would be 2 into limit x is tending towards 0 minus sine 2x upon x the whole square. In this case, what is incomplete? The coefficient. So for balancing the coefficient, what we are doing is multiply and divide by 4. So the answer which you would get is 2 into limit x is tending towards 0 minus sine 2x upon 2x the whole square into 4. We know that 4 into 2 is 8, and we also know limit x is tending towards 0, sine x by x is 1. So 2 into 1 into 4 would give you 8. You remember equation as f of x is already continuous at x equal to 0. Hence, the equation is already satisfied. You know that the limit f of x is tending towards 0 minus is equal to f of x at x equal to 0. We have just now found out the value of this f of x as what? 8, and the required value was k. So hence I can say that the value of k is given by 8. So students, keep learning, keep solving such problems. See you in the next module. Thank you.